talk about having kids in our projects and how to, I don't want to benefit, but have the benefit of working with children, with the young people in this presentation, because for the last 2 years, I'm working very close to the children. And I felt that I should share this feeling with everybody. So today's topic will be working with children and what we did with children. My first slide is this: why. I will not tell why, but when we finish the presentation, I will be talking about why, and I will tell you why. So who I am, I'm a space enthusiast. I'm originally an electronics engineer, but I'm interested in space. So now I'm an astronomer. I did my master's degree at astronomy, so I'm really interested in space and any space science. So instead of talking what can be done, how to communicate with children, how to get children or kids involved in your projects, let's talk about what we have done already. So I would like to tell you what Mars on Earth project did, or to be with the children and get the kids involved in our projects, and what benefits we had out of this. For this, I would like to first talk about the Mars on Earth project. Mars on Earth project is founded by 4 people: me, Ruha, Neil, and Serenay. Then we grow very fast, very fast. We are a non-profit community, not an organization, not a company. We are just a non-profit community with volunteers gathered together. We have engineers, teachers, instructors, researchers, radio amateurs. In various professions, we have volunteers in our team. And of course, we are working for the future. Kids are our future. So we started working with the kids. That's the key point. Just some numbers about the Mars on Earth project. Originally, we started in Turkey in Turkish, but then we figured out that there are many countries interested with this Mars on Earth project community. So these are the countries in alphabetical order that get involved in our projects, or they are in our forum pages. We are doing some small projects with these. I think we are around 130 nowadays. Our aim is to raise the awareness about space. When we say space nowadays, the brilliant word is to say Mars, because everybody is looking for how we will reach to the Mars as human beings, how we'll settle up in Mars. So it's a good step to start with Mars to get the awareness of people or the kids about space. We are trying to write documents in people's or kids' native languages that they can read and understand what we are talking about. And we are trying to start some open source projects to get people involved and train each other about communication, satellites, radio astronomy, deep space networking, and that kind of things. But the priority we have is the kids. So we have students, schools, teachers involved, and we are trying to build up some small Mars bases on schools, which are IoT, Internet of Things based, and which can communicate with each other and with servers. Just real Mars bases, but they are on the Earth. Of course, our main goal is to have a bigger one on the Earth, which we are planning to have 1,000 meters square area, which I will show here, to handle some Mars projects, just like the space centers all around the world. You go there and they train you about the space. We are trying to build a simpler or smaller one of that, but we are trying to document everything in this area. So every number here you see, we started documenting what should be there, how will be the procedure to have that activity on site. the documentation and sharing that documentation is our first focus before building this area, because we don't want to build it only in Turkey or only in Azerbaijan. We would like to have this kind of environments all around the world, and we would like to connect those to each other, just like we will have in real Mars environment before being Martians. Of course, these areas will have some command and control centers. We are trying to develop the command and control softwares for those areas as well, for those bases. Some sample activities we already completed with children. For example, we started a campaign. Maybe I don't want to say call it as a um, um, contest, but it's a campaign. Yeah, we ask kids to draw their thoughts about Mars and life in Mars, and we promised that we will send 10 of the pictures. We will send them to space with a special protocol called KGSTV. We were expecting maybe 10, 20, not more than 30 pictures, but we got around 160 pictures from the kids. And one thing, and to send 10 pictures, we should take our one weekend, let's say one day, because it's a very slow process to send those pictures to space. But we get a message from one of the teachers. She said, I get a saying from one of my students. She said, maybe my picture will not go to space, but me attending to this campaign and sending my picture, most probably somebody else's picture will go to space. And when we get this, we decided to send all the pictures, and it took us about 4 or 5 weekends to send all the pictures to the space over the QO100 satellite, which is a geostationary satellite. And then we got around 16 countries. Lots of people received these pictures from Earth. I think around 120 different stations over the some of them over the internet SDR receivers, some of them with their satellite dish receivers. They received those pictures and sent them back to us, and we sent some award certificates to those attendees. And the children who learned that their picture went to space, you should see their faces. It was a brilliant moment for us. And also we asked the young people, the children, to write some stories about Mars, and we got a lot of stories from children. So we have some animators. So the animators draw the animations of those stories, and we publish them. We'll publish them on our webpage. Also, we are in close contact with the Habitat Marte in Brazil, which has analog astronaut trainings. We have 2 attendees. Now we are trying to prepare our own analog astronaut trainings. In the pandemic days, we are planning to do that virtually, and which we can have attendees from all around the world. We have a Kids Space Force. It's a team of kids and pets. They come together and talk about space. It's a playground for the kids to talk each other about space mostly. Model Mars bases, I will talk about that later, and the Mars rover and Fox Hunting satellite. I would like to go faster because I think I only have 20 minutes, and if you leave me, I can speak for hours and hours. These are the schools and the villages. We are trying to prepare or convert some small areas in the village schools into space centers, or let's say Mars bases. Now we have 2 active Mars bases. One is Mars 77 in Tokmak village, and Mars 09 in Kuşadası. And these are some pictures from their activities. Also, for example, in Tokmak, we prepared a time capsule. While building the environment, we prepared a time capsule. We asked kids to write their messages to the future. and we buried that capsule underneath the building, which most probably will be out of that area in 50 years, 100 years, maybe more, and somebody will get and read those messages, what the people in 2021 were thinking about the future. That's one of our um, projects, the Kids Squad. I talked about that. We have a lot of kids plus 4 pets, which is fed and grown by the kids of this squad remotely. What is Marspace? We prepared all the documentation, details, drawings about how to build a Marspace by buying some components from the supermarket nearby or a warehouse nearby and build that Marspace, and how to build some Arduino-based or microcontroller-based sensors and attach them and connect this to our Marspace IoT servers. And for those who cannot find those warehouse or who are not good at with handcrafting, we prepared 3D models of the same environment as well. So you can use a 3D printer to print a tiny, small Mars space. You can put it on a table in your school, at your home, or wherever you want. And while having the sensors on board, you can connect this to the IoT server environment. And each station may or may not have a keyboard and a display which the owners of these stations can communicate with each other over the IoT server. And also you can monitor the the Mars spaces built over the web page on the dashboard. And the rover, we have tiny rovers now, but our goal is to make a big rover. We are trying to build the software architecture for this. This is a rover that you can control remotely over the internet with the real latency that you will have controlling a rover in Mars. Like controlling a rover, which is on Mars, is 8 minutes to 20 minutes of latency, just to make kids to feel that there is a latency. Light is not fast enough to travel even to Mars and back. It takes roughly 20 minutes for the light to go to Mars and come back. And this will be a good learning point for kids as a starting point. Of course, we have the servers that the schools and home Mars spaces are connected. We have some other campaigns or contests for naming our projects. Um, yeah, the pictures drawn by kids. This is just the thumbnails. Maybe next chart might have the pictures. You can visit our webpage to see all the pictures. I promise you that you will love very much each picture when you look into the details of those. We sent all these 160 pictures with the KGSTV protocol over the QO100 satellite. And of course, we assume that while transmitting these signals to the satellite, it also went to the space behind that satellite. Maybe some aliens got those signals as well. Space will be the playground of the next generation. That's what we believe in. Because let's say 40 years ago, 50 years ago, when you say satellite, it was the business of scientists in closed and clean environments, very hard to reach or see closely. But today's, not only the universities, even the elementary schools are having STEM projects to build some satellites. That's a great step. And it was maybe Neil Armstrong's chance to get a footstep on Mars, but I believe every young kid now has the same feeling for having a footstep on Mars. So that's what we believe. And for having fun with space makes kids attraction to the space. For example, we prepared an activity to get kids familiar with satellites and antennas and communication. We asked young people to record their messages to be sent to space. They recorded some messages like about their feelings about space, which is 15 seconds long. then a secret word. And we send those secret words to the satellite and back to Earth uh, on a predefined random frequencies. And we ask people to catch the frequency, catch the message, and get this hidden word, hidden letter. Then get all the hidden letters together to get their secret sentence. And who sent us the secret sentence got awards from us. And we got very, very good attendees and kids attending to this activity, learning how communication goes on. Also, we started asteroid search campaign in parallel. Um, I think I'm not over time. If I'm over time, please inform me. Um, yeah, asteroid search campaign. We applied for as a team to be part of the International Astronomical Search Collaboration. We are not selected for this turn that we got the news today, but in the next turn, we will try to be part of that. What is that? You get some data from NASA archives and you do some searches on them and you send the results if there's a probability of an asteroid. Of course, we are doing some radio astronomy and deep space communication projects. For example, this is my backyard with a 3-meter dish and a 21 centimeter hydrogen observation station, which we are now finishing all the requirements to be to have the station accessible over internet for the kids. So kids might choose a point in the space and schedule a time frame. Then they will get data for 21 centimeter hydrogen line from that point of the galaxy. And maybe they will learn how to work on that data, which will who can be the scientists of the future, I hope. So as I said, we have many trainings like astrobiology, communication, monitoring space, that kind of trainings. We are always with people and kids mostly. As I said, we have 2 analog astronauts, Nurhan and Zeynep. One is astrobiologist and the other is molecular biologist. They attended to Brazil's analog astronaut missions, and they are now preparing mission for our own Mars on Earth analog astronaut trainings. You can check what is analog astronaut training on our webpage. Of course, we are in contact with many of satellite projects, mostly built in Turkey, like the one you just, Muzaffer, presented. Thank you, Muzaffer. Also, Grizu, as you see on the right-hand side, is one of our projects. Is the 67 Grizu 263. But we have many other CanSat and UAV projects supported by our team. And these are the projects we get involved, even me personally, in the past. So TinyGS is another era that we are trying to get young people. There were no stations in Turkey or Moab areas. Now we have many stations in those areas with TinyGS ground stations, which is you can build just a $10 to $20 receiver and receive and send data to satellites. It's very easy to build. So we are having this as an activity in our projects within the schools and also to support this TinyGS community. So let's come back to the power of why. Maybe you heard of five whys. To get to the solution or the root cause of something, you need to ask at least 5 whys. How can I say? In a loop. When you get the answer, you should ask another why. Recursively, you will get to the result or the root cause after at least asking 5 whys. Why? The question why is important because kids like this question very, very much. But when you grow up, you forget to ask this question why. When you tell the kid may ask you, what is this? You say it's a car. Then you get the question, why? Then you think about why it's a car. Because it has four wheels and blah, blah, blah. Then you get the question, why? Then you explain it, blah, blah, blah. Then you get the question, why? And you learn um, teaching something to a young boy or girl is to answer all those whys. For example, you say, she asks, what color is this? You say red, and the answer will be why. So you have to explain that. So when we grew up, we forget the power of this why. All scientists use this, the power of why. All scientists ask why to get to the result. And as I said, when we grow up, when we grew up, we forget asking why. So having young people, young kids in your team will remind you that question again and again. So I offer you to get at least one next generation volunteer in your projects. If you are a company, go to university and get a volunteer to your team. Um, um, or if you're a university group doing some research on satellites or space, go to high schools. If you're a high school group working on something, go to elementary schools. You will find, you will see the benefit of having younger people who is asking you why, and your team will start thinking wider. For wider thinking, get the next generation on your team. So I will finish my presentation by asking this question. We will hand over everything to them soon. They will grow up and we will hand over everything to them. And why not now? Thank you for listening me. Please visit our marsonearthproject.org. It's mostly in Turkish now, but you can use Google or any translation tool in your browser to translate that page. Thank you for listening.